This video we're going to look at some interesting series which is also useful as tools later on when we learn certain tests for determining the nature of series. This is a special series. It says show that this is convergent. Now this is a very standard trick which is um, you'll think of this as similar to partial fraction. What we notice here is that I can rewrite 1 over n times n plus 1 as 1 over n minus 1 over n plus 1. You can verify, right? Because you get n plus 1, n plus 1 minus n plus 1, which becomes 1 over n plus 1. This means that summing this from 1 to infinity is the same as summing this subtraction from 1 to infinity. But if I write this out, for n equals 1, this is 1 over 1 minus 1 over 2. Then n equals 2, so it's plus 1 over 2 minus 1 over 3, plus 1 over 3 minus 1 over 4, plus 1 over n minus 1 minus 1 over n, so on. What you notice here is that these alternating terms all cancel out. What you're going to be left with is the first and the last term. So this actually equals 1 over 1 minus 1 over n under the limit as n goes to infinity, and that equals 1. This is called a telescoping sum, which means that all the inner terms cancel out and you're left with just the first and the last term. So obviously it's convergent and the sum is exactly 1. Okay, the next special series is called a harmonic series, which is the sum of the natural numbers but inverted or reciprocated. And we have to show that this is divergent. To show something is divergent means that the sum must equal infinity. That's the goal. So here's the trick that we do. This is what we are trying to show is divergent. We observe that 1/2 let's see. Yeah, first of all, we observe that, let me get rid of that. 1, 2. The trick that we're going to use here is called grouping. This can be written as 1 plus 1/2. Now let's look at this. If I replace 1/3 by 1/4 and I leave 1/4 as 1/4, this actual sum is more than this because 1/3 is more than 1/4. Similarly, I replace each of these by the last term, which is 1/8. And since each of these is more than 1/8, the sum is definitely more than 1/8. But then what's happening here, this is 1/2, this is 1/2, this is 1/2. Similarly, for the next one, we do 16 terms which are, or 8 terms which are 1 over 16. So we get 1/2 plus 1/2. And this sum, if you add half infinitely many times, you're going to get infinity. So this sum is more than infinity, which means it diverges. Okay, that's it. Next video, we're going to learn certain tests which can be used to directly check if certain series converge or diverge.